So for everyone joining, again, have your sound muted, video on, and log on to Google Classroom, and please start and complete the do now. I see a couple people have completed the do now, so if you have, there is a homework 1 packet poll, which I'm going to chat to everyone. And I would like, it's just a really quick poll. So I would like for everyone to complete this. I chatted the URL into the chat just to get a sense of how you guys felt about it. And then, yeah, I'll discuss that in a second. Hey everyone, hey Kalia. Hey Jordan. Okay, cool. So thanks to Bear, thanks Happy Dot, thanks Ruchal for completing the do now. Awesome. Awesome job, everyone. Looks like everyone who's answered it so far has also gotten it right. So good job to you three. Yeah, for everyone joining, please start and complete the do now in Google Classroom, and you'll have 4 minutes. Then get organized, get your notebooks out, and then also there is a homework 1 packet poll that is very quick. I'm going to chat that in the meeting chat again for everyone who just joined, just to get a sense of how you guys felt about it. But yeah. Also, for everyone joining, I'm hoping I don't run into Wi-Fi issues today, but my family is like doing something with the Wi-Fi, so it's possible it like cuts out, in which case that'd be kind of bad, but we would just have to deal. So I'll give a couple more minutes for the do now, maybe 2 or 3 more minutes. Gonna take a look at the homework packet poll. Okay. Okay, getting a wide range of answers in the poll, so I'll decide what I want to do about that. That's kind of the reason I haven't yet released the second homework packet, just because I wanted to get a sense of everyone of how they felt about the first one. I'm definitely getting a wide range of answers, so I'm not exactly sure what I want to do yet with the next homework assignment, but I'll probably decide that very soon. Yeah. Hey Ashley, hey Favor. For everyone joining, please have your sound muted, video on. You don't have very long now to complete your do now, but see if you can get that done as soon as possible. I think if you, I think theoretically you should be able to solve it pretty quickly. It is an intermediate value theorem problem. Gonna give maybe 1 or 2 more minutes. For everyone who has completed the do now and has gotten organized, again, I'm gonna scroll through. Just try to make sure you have your camera on for anyone who's not on the video off permission list. Besides that, I am going to chat the URL for the homework 1 packet poll I would like to get some feedback on how you guys all felt about this first homework packet. And actually, another question, can you guys message me? Is my video and everything coming across fine? Because just to update again, my family is doing something weird with the Wi-Fi. So like, okay, cool. I'm getting some okays. There have been a few days few times this weekend where like my internet just completely cuts out, like for like more than 10 minutes at a time. I hope that does not happen today, but if that does, you guys might be in luck, and then I don't know. Okay, so I'm gonna give 1 more minute for everything on this. Okay, I got one message saying the audio is cutting out. I'm gonna actually switch to phone audio really quick. So this might give everyone like 1 or 2 more minutes, but okay. Okay, I don't think this phone audio thing is actually gonna work right now, so I'll get that sorted out as soon as possible. Hopefully you guys can hear me okay. If the audio is ever cutting out like really bad, please just message me. And I will like try to pause for a few seconds. Okay, cool. So now we're gonna move on to notebook setup. So please take 30 seconds or so to get your notebook set up. Again, just have your date. The topic we're tackling today is derivative/tangent line sketching, and then have your name. And then you guys know how to set up your notebooks for your like own benefit. So set that up however you'd like. Okay, cool. So hopefully everyone has their notebook set up. And we are going to head to our content today. So first, let us begin with our do now. And could I get someone to volunteer in chat to kind of walk us through how they attempted the do now? So it seems like a large portion of you guys got the question right. So again, just send your name in chat.
Talia, would you be able to come off of mute and share what you did?
So for the interval 6 to 14, I substituted f of 6 and got 1, and then for f of 14 I got 3, and then I realized that in between 4 is, I realized that the answer for 4 is in between 1 and 3. I mean, not in between 1 and 3, so it's above.
Awesome. Yeah, that's definitely the right train of thought. So if you guys remember, so our first thing when we're testing with intermediate value theorem is to determine whether the function is continuous or not. And then so on the interval of 6 to 14, our function would be continuous because you can kind of think about it just by plugging in every number between 6 and 14. Well, you don't have to actually plug in every number, but if you look at plugging in 6 and 14, you'll notice that like nothing is violated. Like square root of 6 minus 5 is equal to square root of 1 is equal to 1. Like that makes sense. We're not getting any like weird values. Like if we plugged in like 0, for example, we're going to get square root of -5. And we all know like square root of negative number, that would be an imaginary number. It's not real. So we're not getting anything weird like that. So on our function of, on the interval of 6 to 14, we are have a continuous function. We are like getting a continuous function. Continuous. And then we just plug in the values that we're looking at. So f of 6, Kalia also already said she got 1 and 3 for f of 6 and f of 14, but we're going to plug in f of 6. We get 6 minus 5 equal to square root of 1 is equal to 1. And then f of 14, I got square root of 14 minus 5 is equal to square root of 9 is equal to 3. So we know essentially that I can draw out a graph here. So from let's say from 6 to 14, right? Our value goes from 1 to 3. But 6 at 1 at 14, it's at 3. And we know that between these 2 points, the function is continuous. Now we don't know what exactly it looks like. The function could look like this. It could look like that, right? It could look like that. It could just be a straight line. But what intermediate value theorem tells us is that then we know at the very minimum, every value between 1 and 3 is covered. So every value between 1 and 3 is covered. However, they're asking for 4. 4 is not covered. Well, another, okay, hopefully my audio is working. Here, I'm gonna, okay, hopefully everyone can hear me right now. So again, so 4 is not covered. A better way to say this is 4 is not guaranteed to be covered. Because 4 could be covered. Like if I drew the graph like this, well then 4, which is over here, is probably part of the graph, right? But it doesn't have to be, remember, because I could draw the function like this, in which case 4 would not be part of the function. The only thing that is guaranteed is that every value between 1 and 3 is covered. So the answer is going to be no. And I believe the reasoning on the do now was like, no, even though f of x is continuous, 4 is not within like the range of f of 6 to f of 14. So hopefully that makes sense. Okay, cool. So next we're going to go into the topics for today. So this will be today's material. And I think today is a really important conceptual day for us to understand what derivatives are. And derivatives make the basis of Calc A. So I'll say like, derivatives are foundation. Oh my God, I cannot write. Calc A. Sorry about that. I'm going to scroll back up. I'll give people like 15 seconds to copy everything down if they need to from the first problem. And then if you want to get started writing stuff down on these two definitions for what is a derivative really and what does this look like graphically, you can do that as well. Okay, so continuing with this idea, the derivative of a function, right, is the foundation of Calc A. And what it really means is that it's actually like, I feel like it's, I'm sure, I think you guys already like learned a lot of this in pre-calc. I'm not actually 100% sure what your curriculum was like in pre-calc, but the definition of derivative is pretty simple. It's just the instantaneous rate of change. Now, how can we think about this? We can think of the instantaneous rate of change as like the slope of the tangent line at a point. The slope of the tangent line. That's about it. It's basically, it's a rate. So when we think of like a graph like a parabola like this, right? What is the slope of the tangent line at this point? Well, if I draw a tangent line to be like this, that slope looks like it's 0. So what does that mean? That means the derivative is also just 0 at that point. Again, the derivative is the instantaneous rate of change, and it's the slope of the tangent line. At that point, what is the rate of change? The rate of change is 0 because the tangent line is flat. Like nothing's, it's not increasing or decreasing, it's at 0. Now, if I were to look at the instantaneous rate of change over here, I can find that out. You can already tell it's going to be pretty negative. I can draw a tangent line and see, oh yeah, the slope of the tangent line is also very negative. So we know the derivative at this point right here is going to be very negative. So, I mean, the word derivative sounds kind of like complex or just mysterious, but again, all it really means is the slope. It's the instantaneous rate of change. Now, we have various ways of finding that out and seeing how that's important, but at its core, that's what a derivative is. So I'm going to make sure everyone has 10 more seconds or so to write down this definition. So you don't have to draw like all the stuff on the side that I did, but I would like for everyone to have the core like words that are written out, written into your notes. Okay, so next we're going to look at this graphically. I actually kind of already covered this. I probably should have reserved that for later, but graphically, it's the slope of the tangent line to the graph at x equals c is the same as the derivative at x equals c. So I basically just did this, but I'll just show it really quick with like a different graph. Let's say this is like a x cubed type looking graph, right? Way in like the positive area, I'm going to have a derivative that looks very positive because the slope of the tangent line at this point is extremely positive, so very positive. Whereas over here, Well, it'd still be positive. You'll notice that when I'm drawing the tangent line, it is also positive. It's sloping way upwards, so very positive. So that tells me the derivative of the graph at that point is also going to be positive. Remember, these are the same thing. The slope of the tangent line and derivative, they tell us the exact same thing. The instantaneous rate of change, whatever words you want to use, they tell us the same thing. So everyone can take like maybe 30 seconds or so to copy down this definition. And then more important than just writing down the definition again is just kind of understanding what a derivative and what these terms mean.
The left side on the bottom is positive or negative? I can't.
Sorry, so Steve, do you mean this area?
Yeah. It looks negative,
so
but you put a positive. Is that a positive sign there?
yeah, it actually is positive. I'm going to draw this out more clearly.
Thank you.
So I drew like a graph that looks like this. So remember, we're always looking from left to right, right? Whenever we're like, whatever, even like reading a book, we go left to right. So from left to right, this is increasing. You notice from here, left, it's over here. Go a bit to the right, it's higher. To the right, it's even higher. So that tells us right here, our tangent line is positive. Same thing here. We're going left to right, it's increasing. Tangent line is positive. If we had the opposite, let's say we had over here, now everything's negative. The tangent lines are all negative. So yeah, in the case of the example that I drew, it is all positive. But thanks for that question. Okay, I give like 5 more seconds. Okay, so now I would like for everyone to take like 2 minutes or so you can just really quickly sketch this graph. You don't have to draw all the numbers and stuff. To be honest, if you really don't want to sketch this graph, you don't have to either, but I would like for everyone to answer the questions A, B, and C. So examine the graph of the function above, and then using interval notation, list all the x values where the function has either a positive slope, negative slope, or 0 slope. Once you have the answers, your answers, please type your name in chat. And I'm probably going to call on some volunteers, and I might also just cold call some people. So please be ready. Again, 2 minutes. Okay, maybe 20 more seconds. Thanks everyone for the answers. If you want to, yeah, okay, awesome, thank you. Cool, Steve, do you want to come off mute and just answer part A for me?
For part A, I said -5 to -3 and 1
Okay. Sorry, could you say 1 to what again?
1 to 4.
Awesome. That's exactly right. If you want to know how to do this with interval notation, so I have the interval of -5 to 3, and then I union it with 1 to 4. That tells us that it's both these intervals. So you probably just did this visually, but can you Steve, would you be able to kind of explain how you knew that these slopes were positive? Might be kind of hard to explain, but like if you had to try, how would you explain that?
I would try to explain it like at those slopes, it's increasing. I don't know the rate it's increasing by, but it visually looks like as though it's going up, like straight up, and it's not going down in any way, shape, or form.
Yeah, I think that's actually a really great way to explain it. So just a way to think about it would be like just drawing along, like you can think about it in however it helps you, but like just drawing along the graph, we're going up. Now over here, Steve, you noted that like at some points it looks like it's going up, but maybe not as much. Like over here, it's increasing, but like not by that much. But what's important is that it's increasing. Just like at the end of story, it's increasing, and it's not decreasing in any way, shape, or form. I think you said, like over here, we can clearly see it's decreasing. So that's not part of our interval. So yeah, it would be a positive slope. Another way to think about it, it's like basically the same way, is just look at the slope of the tangent lines. If I draw a tangent line to the graph here, right, the slope is clearly going up. The slope over here from 1 to 4 is clearly going up. So yeah, those are the intervals in which it's positive. How about Mubarak? Could you answer part B for me?
-3 to 1.
Gotcha. And then, cool. Is there any way you thought about it, or was it kind of the same way as Steve in terms of just looking at the slope?
It's if we're reading it from left to right, the starting value is positive and the ending value. The starting y value is positive and ending y value is negative. Obviously, it's decreasing. And also, if A is true, then anywhere, no. I was just saying because like in A, from -5 to 3 is positive, and from 1 to 4 is positive. So I would assume that B is negative.
Yeah. I think that's interesting logic. So that last part you're saying, if it's not positive, then it must either be negative or 0 slope in this case. So it's also important to remember it could be 0. But yeah, it's a good way to think about it. And then again, you could just look at this in terms of the slope of the tangent line. So you can see clearly the tangent line is sloping downwards. It's downwards means negative. Here it's sloping downwards. So from this interval, it is negative. How about for the last part, part C?
I said when I get forward to infinity, because we can see that there's no slope, it's just like a straight line. I said that.
Gotcha. Wait, sorry, your answer was kind of hard to hear, but I did hear you say that the slope has to be a straight line. So cool, okay, so yeah, so that's exactly right. So when we're looking, again, just like we looked at positive slopes and negative slopes, when it's a 0 slope, well, then it's very easy. The tangent line has to be 0. And the tangent line is 0 at these points, because we can see like, kind of another way to think about it is like, if the slope goes from positive to negative, then it must cross 0 at some point, right? Because you're going from positive to negative, it must cross 0 at some point. So we have these intervals where it's going from positive, from -5 to 3, it's positive, and all of a sudden it's going negative, right? Oh, sorry, it's -5 to -3. Apologies for that. If it's going from -5 to -3, and then from -3 to 1, it's negative, well then going from positive to negative, it must cross 0 at some point. And it crosses 0 at -3. You can see how these intervals, like, they overlap in that way, or they like don't overlap, because at -3, it's 0. The same thing happens at 1. You can tell because the slope of the tangent line, if we draw it, is 0. And then also from 4 to infinity, it's also 0. You see they draw that here. And this is more than just a single point. This seems like a whole interval from -4 to infinity. So has 0 slope, the function has 0 slope at x equals -3, x equals 1, and 4 to infinity. So this one's kind of unique because it has 0 slope at like individual points and also an actual interval. So I'm going to give everyone a couple seconds to write this all down. Okay. I think most people should have had time to write it down while I was talking. So I'm going to move on to, now we're going to start, this is like the big task that we're trying to learn today, is how to look at a function, right? Let's say this is f of x, this is f of x, and then be able to draw a derivative / slope graph. So this would be f prime of x, f prime of x. So I'm going to do this example really quick, and then this problem is kind of hard, but I'm going to try to have you all do it too. So if everyone wants to take like 2 minutes to, well, actually less than 2 minutes, like just like 30 seconds or so, just to like kind of do a rough sketch of these graphs in their notebook. And then make sure you put some space in between the two graphs also. So don't draw them right above each other, because I'm going to write a few notes. Okay, so let's get started on this first problem where I am essentially drawing f of x into f prime of x. So drawing a derivative / slope graph. And before I start, I think I'll clarify like a way to make these problems like a structure to think about them. So there's two things we want to think about. One is the sign. And that's what we just did above. We want to figure out, is the slope positive or negative? That's the first thing we want to figure out. Just pay attention to see like which intervals is the slope positive, which intervals is it negative. Now we already looked at this previous graph. We kind of saw like, already like over here, it seems positive, right? Because everything is going up. Between here and here, it seems negative. Everything's going down, right? And then from here to here, again, it seems like it's all, from like this interval onwards, it seems like it's all positive because everything's going up. So that's the first thing we want to think about. So the sign, is the slope positive or negative? Next, 2 is steepness. I think this part is slightly more challenging in terms of drawing, which is how positive or negative is it? So this is asking like the magnitude. It's like, okay, we know it's positive or negative, but like how positive, how negative? Is this like 1,000 extremely positive, like it almost looks like it's going straight up? Or is it like 0.2, where it's like almost looks like it's a 0 slope, but it's like slightly positive? That's the second thing we have to look for. So like, for example, for this first graph over here, let's say if I draw a tangent line, it's like clearly very positive. I don't know what the slope is, probably like 8, 9, 10 over 1. Whereas the slope over here, right, let's try to draw over here, right, it's still positive, but it's not very positive. It's like pretty close to horizontal almost. So this slope is probably like what, like 0.2, 0.3. It's definitely not even 1, right? A 1 slope looks like this, right? Because it's 1 over 1. But yeah, so that's the second thing we have to think about. So we have to think about where is it positive, and then where is it positive or negative, and how positive or negative is it? So now when we're actually drawing, we can start by drawing just tangent lines just to see what we're getting. So let's say over here, it's very positive. Over here, it's positive, less positive. Positive, not as positive. Now we're going to the negative area. You can see it's pretty negative. Over here, it's negative, but it's not like super negative, and then it goes super positive again. So now we have a picture of like what the slopes of the tangent lines, like how positive or negative they are. So when we're mapping this out to on a derivative graph, a good way to start, a good like reference point is, okay, we have all these positive and negative values. Let's just find where is the slope 0. So where is the slope 0? And this is really useful because we can just mark it down. So the slope is 0 at -1, right? We already determined that kind of from the previous problem, and this is like the same graph. So at -1, why this is useful is because we can just mark it down as a 0. So at -1, on the y-axis, we have it like this is 0, right? So we mark down as 0. Now at 2, right, the tangent line is also horizontal. We showed that. So at 2, it's also 0. Now everything in between, we had kind of already have figured out. So to the left of -1, right, to the left of -1 here, and to the left of -1 here, we see that the slopes were always positive. We saw how the slopes of the tangent lines were all positive. So that means if it's all positive, nothing's over here, right? Because this is all negative. Everything is up over here. All we have to do is pay attention to, here, I'll draw an X here. So all we have to do is pay attention to how positive or negative it is. We already figured out the sign, everything's positive. Now how positive or negative is it? So starting at -3, it's very positive, right? So it's up here. But then it gets, as we progress, it gets less and less positive. Slopes are less and less positive until it gets down to 0. So the slopes come from here, they're super positive. Slopes are super positive. Now it's getting less positive, right? The slope is less positive until here, the slope is 0. So that's what we're seeing here. It goes from super positive to less and less positive until it hits 0. Right? Now, how about from -1 to 2? Well, here we see that all the slopes are negative, right? From -1 to 2, all the slopes are negative. They're all going downwards. So that means from -1 to 2, nothing, from -1 to 2, nothing is up here. Everything is down negative. None of it is positive. And how does that look? Well, it starts off as Well, it just hit 0, right? So now it's slightly negative, but it gets more and more negative until it goes back to 0, right? Because it's more negative at 1, but once it approaches 2, it's like, okay, I'm not going to be as negative because I'm going to start going positive soon, so I'm going to go back to 0. And then for this final portion, all the slopes are positive again. So what does that tell us? From 2 onwards, nothing can be here, right? Because all the slopes are positive again. Our sign test told us that when look at the sign, is the slope positive or negative? They're all positive over here. It's all going up. So when we're drawing our slope graph, nothing is down here, right? Because this is all a negative area. So how positive or negative is it? Well, it starts off as barely positive, right? Because it's just coming out of a 0 slope. So it's barely positive, right? So it's over here, but then it gets more and more positive. So that is what our graph ultimately looks like. If we erase all the rest, we kind of see it looks like a parabola. So obviously this wasn't the best sketch, but if I were to redo it really quick, it would look like this kind of. So it's really just a parabola. And that actually kind of makes sense if we think about this. This is like a power rule thing almost. So this would be x cubed. And when we do power rule, I'm not sure if you guys, I think you guys probably did that in pre-calc, but power rule of x cubed, 3x squared. This is just an x squared graph. X squared is a parabola. So yeah, it makes sense with what we know about derivatives. I'm gonna give everyone like 20 seconds or so to copy everything down here.
I had a question.
Yeah, go for it.
So, for the negative one, why was that whole side flipped? Like realistically, like why was it flipped?
Sorry, can you wait one sec? Let me erase this. What part are you talking about that's flipped? From -1 to where?
Oh no, from -3 to -1. I mean.
Okay. Yes.
Yeah.
So from here to here, you're wondering why it's flipped on this graph?
Yeah.
Okay. Yeah. So I think this is where derivative graphing can be kind of confusing. It's not really like we're using this graph as reference, but our derivative graph doesn't have to look like this graph at all. What we're concerned about only is the slope. So when we look at here, it's not that it's flipped. Like, so would you be able to tell me here, is the slope positive or is it negative?
It's negative. Oh, you're going when it's increasing, or are you saying it's in the negative area, or like is it? I'm confused. My fault.
From -3 to -1, is the slope of this graph right here, is it positive or negative?
It's positive.
Okay, cool. So now we know that it's positive. Now the only thing that tells us then is that on this graph, on the second graph, right, we have to draw in the positive area. So it has to be over here. It has to be above this line, right? This line is what separates. This is positive, this is negative in terms of the y values, right? So that's it tells us that it has to be positive from -3 to 1. So even though it's like, it looks like this graph is way down here and like, oh, we're thinking like, oh, maybe it should match. We should draw something over here, right? That it's not relevant at all. All we care about is the slope. That's the only thing that we care about. So the slope here is positive. So we have to draw something positive. Now, when we look at the slope here, right, from let's say 3, the 3 area, it's also positive. That's why we drew it over here. That's when we drew everything. It was like this.
Oh, so if the slope is negative, then it would stay in the denominator, the bottom part of the graph.
Yep, exactly. So when we looked at, let's say at 1, right? At 1, the slope is negative. And then when we draw 1 here, look, it's in the bottom part of the graph. Yeah, so hopefully that makes sense. I think this is one of those things that comes along with practice because it can be quite confusing at first. I definitely think it takes some getting used to being able to draw from f of x to f prime of x easily. I'm
I
gonna
get
give
it.
everyone, okay, cool, yeah. I'm gonna give everyone like 2 to 3 minutes to try to solve this second graph, and then I'm gonna show the answer at the end. Or if someone has like, if someone thinks they really have this answer, I'll try to show this in like the last minute of class because I understand we are running out of time. But I will say this problem is, this one's more confusing, and I think it's not as intuitive as the first graph that I showed. So just to give some tips, I would draw tangent lines at different places, look at the slopes, and then just plot the slopes down on the second graph. So probably just 30 more seconds actually, just so I can draw it and have a bit of time. If anyone has an answer that they like, maybe kind of want to walk me through, just share your name in chat. It is kind of a tough problem. So if you can solve this, that is great. Good job on you guys. Okay, if anyone has even like an inkling, just chat your name. You don't have to have the whole problem out, figured out. If not, I'm just gonna walk through it in like 10 seconds. Okay, there's like 1 minute left of class. So I'm gonna try to walk through this really quick. Okay, so the first thing I noticed is that, okay, this one, there's a bunch of, the first graph, right, there were a bunch of slopes where like it was 0. Well, here we don't have any slopes where there's 0. Then no place is the slope 0. So that kind of stinks. I don't get to mark down zeros at any point in this graph to help us reference like what we're looking at. So I'm just gonna just brute force it. From the left to the right, I'll see that this slope is negative, right? It's very slightly negative, but it's negative. And then as we progress, it gets more negative and then it gets super negative, right? At this point, the slope is super negative. So of course, I'm down here super negative. You'll notice this graph looks the same as the left graph, right? Well, I mean, sometimes that happens. So we're just gonna leave it like that. And then from this graph onwards, the slope starts off super negative. So I'm actually starting off way over here, right? Because the slope is super negative. So I'm starting off super negative, and then it gets closer and closer to 0. So this is what our second graph looks like. It's almost like I took this part and flipped it over. Not that that actually reveals anything, but it is what the graph looks like. Ultimately, what I did was just look at each of the slopes and then plot them. So it starts off super negative here, goes to 0. So yeah. Hopefully you can copy that down. Sorry for running out of time. Make sure you turn in your exit ticket, notes, etc. Look out for a homework packet if I release it. And then for anyone who has not turned in their homework packet yet, please do that as soon as possible. I sent out an email reminder for anyone who has not yet turned that in. So there are some people who I have not submitted. Besides that, thank you for coming to class. Sorry for taking that extra minute. And I'll see you all tomorrow. Bye, Clarissa. Bye, Kayla. Thanks, Kayla. You too. And if anyone has questions, I can stay for a bit after class.